Problem number 3. A train starts from rest. Speed equals 0 mile per hour at 12 noon. And the speed increases at a constant rate. So the rate of change of the speed is constant, and the rate of change of speed is acceleration. So here we know that the acceleration is a constant. Say a of t equals k. Okay. Now remember that the relationship between acceleration and the velocity is that the derivative of the velocity is acceleration. So we want to find, okay, or you can put here that acceleration is dv over dt. So we want to find a function such that if we take the derivative of that function, we get back k. And what is that function? It is kt plus another constant. But here we know that the train starts from rest, which means that when t equals 0, the velocity equals to 0. But if we plug into this formula, we know that the velocity at t equals 0 is c. It means that c equals to 0. So we don't need this constant. So the velocity equals to kt. Okay. Now, here on the second statement, it is given that the speed increases at a constant rate until 12:15, when the speed equals 64 miles per hour. So let us set up that the time is given in hour. So 12:15 means 1/4 hour after 12 noon. So the statement says that when t equals 1/4, v equals 64. So v of 1/4, which is k times 1/4, equals to 64. Now solving for k equals 64 times 4, which is 256. Okay. And now the question asking how far does the train travel from 12 to 12:15. So basically it asking about what is the distance when t, so when t equals 1/4. Let us write the distance function as d of t. Okay. Remember that the distance, the velocity is the derivative of the distance function. So now the velocity is equal, okay, here we have k equals to 256. So from this, if we plug in back k equals to 256 over here, we have v of t equals to 256t. Okay. Now the velocity is the derivative of the distance function. Now what is a function so that the derivative of that function equals to 256t? So basically it is the opposite process of taking derivative. Remember that when we're taking derivative, the exponent that appear in this t variable will be decreasing. So when we apply the reverse process, the exponent will increase by 1. So we know that here we should have something t squared, and we need to adjust the coefficient. So what should we put to this coefficient in order to get 256 when we take the derivative of t? So you can verify that we need to take this equal to 256 divided by 2. And to check that, just taking the derivative of this, just take the derivative of this, you will get back 256t. But not only this function that give us the derivative equals to 256t, any kind of this function plus a constant will do. So let's see. But again, okay, so this should be okay. When t equals 0, then the distance is 0. So plug in the t equals 0 here. We have when t equals 0, the distance is c. It means that again that this c must be 0. So we don't need this c. You can erase it. So this is d of t equals 256 over 2t squared. And here we want to know how far the train traveled from 12 to 12:15, which is the same thing as saying what is the distance when t equals 1/4. So from here we have d of 1/4 equals 256 over 2 times 1/4 squared. So 256 divided by 2 is 128 divided by 16. And I think it is equal to 8. So the answer is B.